All right, so welcome back, everyone. Today we're going to be doing our final workshop in the main lecture series, workshop 10, called Gamebook. And today with Kenneth, I'll be working through kind of an end-to-end process of adding a game feature to this chat book or this cat book website we've been working on so far. So there's many different types of games, and I'm sure everyone is like familiar with at least one of these games, whether it be Minecraft, Among Us, League of Legends, or many other types of games. And when you first think of like all of these different applications or games that exist, they may seem very different than the types of things we've been working on so far in Catbook and web dev in general. But as you'll kind of see today, lots of the topics and concepts that we've learned over the course of the past 2 weeks can actually be extended and built out to create some of these amazing games. Today, in particular, we're going to be working on Agario, and we'll get more into that in a bit. But just first to kind of like describe what is a little bit different about a game than a normal website that makes it initially challenging at first. The first is that there's complicated game logic and state associated with every game. For example, things like how many players are in the game, whether or not someone is winning the game, scores, stuff like that. This all will need to be stored and coordinated between all of the players of the game. Secondarily, it's pretty important that games are performant, meaning that they run fast and smoothly. And the reason for this is because if we have users that are playing the game, we want them to be able to feel like they can actually move the way they want or interact with the game the way they want, rather than having like super long delays between their inputs and the consequences of those inputs. As I mentioned, we'll actually be able to extend a lot of the infrastructure we've been working on over the past few weeks to build out this game page. And again, just to go over what we've learned so far, we have users or clients that communicate with a backend server. That backend server can help us with things like authentication, and it can also talk to backend databases, which will be able to store lots of information that we'll want to be using in our game. We'll introduce a few new concepts. The first is the one I was alluding to before, which is the game state and the game logic. All of these things will live on the server, and we'll kind of see how we can have the clients update that game state and make sure that they all agree on the same game state to display to the users. The next thing that we're introducing is a new component called the HTML canvas, and kind of exploring what exactly this is. An HTML canvas is essentially a specialized HTML component that allows us to draw images and shapes on them. The reason this is helpful for us is because, as you can see on the slide, if we draw an image that's slightly different very fast, we can kind of create this illusion of motion. So this is called animation. And we'll be using this technique to kind of animate our game. As you'll see, we'll be able to have players moving around the screen and more. One thing to note about this HTML canvas is that it uses a slightly different coordinate system than a normal coordinate system. So we're all familiar with this normal Cartesian coordinate plane with X increasing to the right and Y increasing upwards. It's worth noting that this HTML canvas actually uses a slightly inverted coordinate system with Y going downwards. So when we're working with this element, just be sure to keep that in mind if we see any unexpected behavior. So now let's just get into what we're actually going to be building out today. We're going to be building a very simple version of the Agario game. And if you navigate to weblab.is/example and click on the game tab, you should be able to play the end product we'll be working towards over the course of this lecture. And here's a example GIF of kind of what this game looks like. As you can see, you can move around and eat food. And as you eat food, your character should increase in size. So I just wanted to take a brief moment here to pause in case there's any questions on like the high level overview of what we'll be building today. Cool. Oh, yeah. So let's dive a little bit deeper into how we're actually going to be going about doing this. As I mentioned so far, we can reuse lots of the concepts we've learned in the past few weeks, beginning with the React component tree. We're going to be adding a new page, so a new component that will house our game that we're creating. And we'll kind of introduce some new features to like enable us to play the game as we want. So here are some things we're already familiar with. We have things like the login that we saw in workshop 8. We have the client socket and the server socket files, which handle some client or socket communication between the server and the client. And we'll be introducing some new files we work with today. For example, the game, the component that I just mentioned that will display the game on our websites. We'll create an input file that will allow us to read inputs from the user. We'll have a canvas manager component, which will manage that HTML canvas component I was mentioning that will be able to allow us to animate motion in the game. And on the server side, we'll introduce a few new files, starting with game logic, which will house all of the logic of our game. So this includes things like the game states and as well as like whether or not there's winners, etc. To kind of look at like how we're going to design the information flow, what's going to happen is on the client side, we're first going to be reading an input. This will call a function in client socket that will emit a socket event to be caught by the server in server socket. Once the server hears that event, they'll call a file or a function in game logic to update the game state. Once that game update happens, we'll have to send all the updates that happen back to the client. So this will happen from game logic to server socket, where an event emission will take place. The client socket will catch that event and execute a callback function that will update the game components, which will pass that information down to Canvas Manager to update what we should animate on the screen. And this is just kind of like a nice stylized view of what we just discussed. One thing to note here is that we'll also be using some API endpoints to communicate between the client and the server as well. And kind of we'll see when we should use sockets and when we should use APIs a bit later in the workshop. This is just that same information flow I was talking about. So again, input will cause a client socket emission to be caught by the server and update the game logic. Then the game logic will send that update back to the client via this socket connection to be updated on the screen. So kind of like I've been talking about this thing called game state, and just to get a better understanding of like what that actually entails, this is things like who's playing, the locations of the players, the colors of the players, and specifically for like this game we're building, the size, location of foods, and whether or not there's a winner. And all of these things compose the game state that we'll be keeping in that game logic file. As I was mentioning, there are these two ways of communication, and this will become kind of more clear why we use one versus the other in the later steps of the workshop. But just as a high-level overview, generally when we want fast communication, we'll be using sockets. And when there's something that's like slower or not super important to execute immediately, we'll be using API calls. And just one more note before we dive into the workshop. There's this JavaScript function that you can call on arrays that's very similar to .map. It's called .for each. Essentially what this will do is it will execute a callback function for every element of that JavaScript array. It's very similar to map in that regard. The only difference is that it will actually mutate the array at the end. But in general, this is like a very useful function whenever you want to apply a callback function to every element of an array. And we'll see like when we're like expected to use this in our workshop. Okay, so let's get started with the workshop. Just as a quick like note here, this will be a very fast workshop. So we do think it's okay if you actually don't follow all the steps live and just kind of like look at what we're coding and try to understand like the reasoning behind it. If you do wish to follow along, feel free, but just note that it will go pretty fast. And what we recommend is like, if you want to dive into this workshop further, for example, if you're creating a game for your website, like definitely go back and watch the recording and then like try to follow along step by step at that point. So let's just get started. To make sure we're up to date, we can git reset hard as we've been doing, and we can check out W10 step one. Or sorry. Okay, so as with any like page that we've been building in Catbook, the first thing is to create a new page in our application that will house this game. In this step, we'll literally just make a blank page. If you remember, we've been building out this Catbook application. And essentially what we want to be doing is just adding a new place to navigate in the nav bar that will bring us to this new page. So to do this, we can start in app.js. And what we'll do is we'll first input that game or import the game components from the file we defined it in, which is .pages slash game.js. Yeah. And we'll want to add it to our router as we saw before so that we can actually navigate to this page. And this will be in this router component. So we'll just create that game component here. We'll pass it a user ID as a prop. And we'll also want to give it a path for the router to know when we want to navigate to this page. The next step is to just add it to our navbar component so that we can click on it and we'll be redirected to that page. So in navbar.js, if we look at line 31, you can see like this is kind of where we add all those links to all the pages. So we'll just add a new link here. And this will use the syntax very similar to the other links that already exist. But instead of navigating to something like chat, we'll navigate to /game. And we will call this, we'll display like the text game in this nav bar. So again, what we've done is just simply add this game page to our router and also to our nav bar. And we should see that if we navigate to our localhost 5050. Okay, so I missed an S. So just /pages. Okay, sweet. If we navigate to our localhost 5050, we should see that there's this new tab here called game. And when we click on it, we will be redirected to like this empty page. So this is very similar to like what we've been seeing when we added both the chat components and the profile components. This is essentially just a blank React page components. So that's all good. The next step is to actually start populating out this page. And we'll do that in step one. So we can get it reset -- hard, get checkout W10 step one. So what we'll do in this step is add some like preliminary logic to that will be like working with the rest of the steps to update the game and display the game. This is what will like the step will look like at the end of the day, where we have this canvas displayed, and we'll be able to draw like players on this canvas. This isn't like a super important thing to understand completely, but essentially the way that we'll interact with this canvas is through this thing called canvas ref. And in order to do that, we'll use this syntax in React called use ref. And this will make more sense when we go through the workshop. So if this like is a little bit confusing, don't worry for now. Okay, so breaking down step one. As I mentioned before, we'll set up a lot of like the preliminary functions to control our game and interact with our game here. And to do this, we'll first look at gamelogic.js. So if we navigate to sorry, I think I forgot to reset here. Okay. So if we navigate to gamelogic.js, we'll see there's some steps that we've annotated that we want to do. So the first thing we want to do is to actually create a variable that will house all of our game state. And we'll call this game state. And this will be an object that has two parameters. The first is whether or not there's a winner. And we'll set that to be null, because I guess when the game starts, there's no winner. And the second field of this object will be a dictionary or an object of players. So this will essentially map a bunch of players to the properties that they have in the game. And we'll kind of like fill this out later. So we'll see what properties each player has in a bit. The next thing we'll want to do is a little bit lower. We'll want to create a function called update game states. And for now, we'll leave this blank, but in the future steps, we'll be filling out this function to actually update game state as accordingly. So this could be like eating food, eating other players and stuff like that. We'll just define it for now so that we can reference it in some other files that we'll be building out. And finally, at the bottom of this file, we'll want to export both of those things. So that's the game state, as well as the update game state function, so that we're able to access these two things in other files. One of those files we'll need to access these things in is server sockets. So if we navigate to server socket.js, and we go to line 13, we'll see here our first step is to create a function which will actually send that game state we just defined to all of the clients that are connected. Since we kind of want like game state updates to be pretty fast, we'll be using sockets for this. So let's create a function that emits a socket event. And we'll call this send game state. And since this is like somewhat confusing, so sorry about that in advance, but like, if you remember before, we used some syntax that looked like socket manager dot get IO dot emit to emit messages to everyone. And what we did was we named this event. In this case, we'll call it update because it's a game state update. And we also passed some information along with it. In this case, we'll want to be passing the entire game state. So we'll access that game state we just defined in game logic with kind of this syntax here. The reason why we can do this, again, is because we exported that game state before in this file, and then we imported it up here as game logic. So the only thing that's kind of weird here is that like this socket manager wrapper is actually just this server socket file. So there's already some like this get IO thing is already defined in our file here, up here. So we can just call that directly. So that may be a bit confusing, but essentially what happened was like the thing that's returned by the function is just this IO object. So we can just access it directly here. Cool. And essentially this is the same thing. So it's just emitting a socket event to all connected clients. So below that, we'll see we want to now create a function that will start our game loop. And I'll just type it out before kind of going into what exactly that means. But this will look like something start running game. This itself will be a function. Which uses this other function called set interval. And again, I'll go into what this actually is in a bit. This set interval will take in itself another callback function. And what we'll want to do is we'll want to call this update game state function we just defined, which remember is like blank for now, but we'll be filling those out in future steps. So eventually this will actually update the state of our game. And we'll want to call that send game state function we just created up here, which will emit a socket event to all connected players. Secondarily, this set interval function takes in an argument, which is a number. So kind of what this does at a high level is the set interval function will take in a callback function and a time interval. And every time interval milliseconds, it will execute the callback function. So essentially what I'm saying here is like every 60 times a second, we will execute this callback function. And what this callback function will do is it will update the game state and then send that updated game state to all of the clients via this socket. The last step we'll need to take in this is to actually like call this function to start running the game. So we can just do that here. And this will start like this interval process I was mentioning. Cool. So our next step would be to also fill out some functions to help with our game logic. So this would be things like spawn player, which can be found again in this game logic.js file. So if we look at line 34 here, we'll see that we want to, like within the spawn player function, what we want to do is initialize a new player with some properties like position, radius, etc. And the way we're going to do that is we're simply going to add that player to that game state object we created before. So remember, we have this this variable up here called game states, and it has this field called players. So we're going to want to add a player to that field, which we can do with this syntax. So this will add a player with ID to this player object up here. And we're going to map it to some properties that belong to the player. So as mentioned up here, there's a few different things. There's the position, which will set to initial random position. And we can actually get this with this utility function that we've already written for you called get random position. We also have a radius, and we've defined what the initial radius for all players should be just in this global constant up here. And it'll have one more property called color, which is the color of the player to draw. And if you look up here, we've defined an array of some basic colors here for you. And what we can actually do is we can select a random color from that array. So what we want to do is, again, access this colors array. We'll index it with this syntax as per normal array. And the index we're going to pass in is something that looks like this. And it's not super important to like understand everything that's happening here, but essentially what's happening is I'm going to select a random integer from 0 to the length of the array. And essentially what that has the effect of is selecting a random color that's defined in this array. So similarly, we'll also need a function to remove players from the game, for example, when they disconnect, or perhaps when they're eaten. So we can see that in line 55, or 54, we have this function called remove player. And essentially all we need to do is remove the player we want to delete from this game state object players. And we can do this with this keyword called delete. I'm actually not sure if we've seen this in JavaScript before, but essentially, if you're familiar with like the Python delete, it works very similarly, where essentially it will just delete a entry in like a particular object. So if I write this, it will remove the player with ID from this player's object. And again, that'll effectively remove it from the game state and thus remove it from the game. Okay, so now that we've defined these helpful functions, our next step is to actually like utilize these functions when we want to perform these particular tasks. So either spawning the player or removing the player. And to that, we'll want to go to server-socket.js at 1.4. You'll see that there's this socket function called add user, and you'll recognize this function from workshop 9 when we define that init socket endpoint. This was the function that would associate a particular user to the socket that it's connected to. So we'll want to add one more thing here is like whenever we associate a new user with a socket, we're also going to want to add it to the game. And we can do that by calling that function we just wrote. So this be game logic dot spawn player. And we'll pass in the ID of the player as this function expects. Okay, so we've set up a lot of the backend infrastructure now to like spawn new players in and send game states to the client. The next step is to actually instruct the client to listen for those game states. So again, these game state socket updates, and then teach the client how to display the game on their page. So the next few steps we'll be working with React on the front end, and we'll start by looking at game.js. And again, like this is in the diagram, game and canvas manager we'll be looking at. So in game.js, if we look at line 17, we'll see this function process update. And this will be the function that we'll use to essentially what it says, process game state updates from the server. We'll use this function called draw canvas. And it will take in the update that's sent along with the socket emission. And it will also take that canvas ref I was mentioning before. And again, this is essentially just a way for React to know that we want to draw on the particular canvas that's instantiated on the page. The next thing I want to do is to actually call this process update event whenever we hear that socket event we were talking about before. So remember we define or we turn on sockets with a syntax that looks like socket.on. And recall that like the event that we're listening for is called update. We defined this event to be called update. So we'll have to listen for that same update event on the client. What we're going to do when we hear that event is we're going to call like this process update function we just defined here, which ideally will draw a canvas for us. Cool. So the next step is to actually like define what this draw canvas means. And to do that, we'll look at Canvas Manager. And there's kind of two things we want to do here. We want to fill out a helper function called draw player, which will essentially be used to draw all of those circles on the canvas to represent all of the users. You'll notice there's like this line right here, which we call convert chord on the X and Y, and we get some new values out. And this is essentially the conversion between like that real coordinate system we were talking about and the inverted canvas manager or canvas HTML coordinate system with the downwards facing Y. So this actually handles all that for us, and we don't need to think about that when we're using the HTML canvas. So we can just directly use this other helper function we've written for you called fill circle, which will draw a circle on the canvas. So if we say fill circle and look at like what arguments this takes in something called the context. This context is very similar to like that canvas ref in the sense that it's just like some property of the canvas that allows us to identify it and know which one we should draw on. The next things we'll need to pass in are like the X and Y positions we want to draw this player. And remember, like we want to use these converted coordinates to do that. So we'll say this should be draw X and this should be draw Y. Finally, the fill circle function will take in a few other parameters like the radius of the player, as well as the color of the player. And finally, what we want to do is actually use this draw player function to draw a circle for every user that's connected to our game. And to do that, we'll see in line 32, we have this draw canvas function. Remember that this draw canvas function was what we called from game.js. And within that draw canvas function, we want to use this draw player function for every single player in our game state. And what we can do is we can actually use that for each function or that for each syntax that I was talking about before, where we want to apply a function for every single value of an array. So in this case, we want to apply a function for every single value every single player in our players array. And what we're going to want to do for every player is we're going to want to draw that player with that function we've just defined. Again, we'll have to pass around this like context, which is again not super important, just a reference to like this HTML canvas element. And what we'll want to do is we'll want to pass it in some things like the position of the player. So the X and Y position of the player. The radius of the player. And finally, the color of the player as well. So again, what we did here in these past two steps was to kind of draw out some infrastructure for displaying the canvas. And this started by listening for socket updates on the client side, and then defining what should happen when we hear those socket updates. In this case, drawing a player for every player that's connected to our game. One more thing that I forgot to do here, but again, we should do for good practice, is that we should write a cleanup function to close our socket whenever we disconnect. So, okay, it's less than 10. Okay. So yeah, just make sure all your variables are typed correctly, or else you'll get like some weird behavior due to undefined. An interesting note is that like TypeScript might actually help fix this. So if that's something you're interested in, definitely check that out. But as I was mentioning, like we want to turn off the socket in this cleanup function, just like we've been doing with every other socket, just to prevent us from having extra sockets open when we don't need them. Cool. So if all of this is done correctly, now when we navigate to our localhost 5050 and we log in, we should be able to see that our player spawns in at a random location and it's displayed on this canvas object on our game page. And if you want to kind of try this out on your local computer, feel free to check out Workshop 9 Step 2. This should run and display everything as this. Cool. Are there any questions about like what we just went through or any of like that control flow? I know it was like pretty fast, but like as mentioned before, we definitely recommend you going back and watching this lecture and then like trying every step by yourselves, especially if you are planning to make a game for your project. Okay, cool. So the next step we're going to walk through is a kind of like a way to let the player move around the screen. So to do that, let's go to our VS Code and then check out step 2. W10-step 2. And the first thing we're going to be doing in this step is to set up some socket functions to facilitate the server-client communication. And we'll begin by looking at client socket.js. And again, I'm going to speed up a bit here just because we're running a little bit behind, but remember that like this recording will be posted and it's not super important to like follow all this live at this moment. So I guess we should also get cool here. Okay. So the first thing we want to do is, as this kind of to-do states, we want to be able to send client updates, specifically move data to the server. I'm just going to type this out first and then explain what each one does. So this function will be called move, and it will take in a direction. And when it hears this, or when this function is called, we'll emit a socket event called move and pass along the direction of that movement. Then if we navigate to input.js, we'll actually want to call this move function to have these socket events. So in input.js, you'll see we have this function called handle input, What this will do is it will essentially be what's called whenever we hear key press. And depending on what the key is pressed, or which key is pressed, we will execute something slightly different. So if we are pressing arrow up, we'll move up. If we're pressing arrow down, we'll move down. And similarly for left and right. If we hear left, we'll want to move left. And if we hear right, we'll want to move right. Also at the top, we should import this function move that we defined here, just so that we're able to actually call it. So this will be at the top, import move from /client sockets. So again, what this handle input does is it will respond to each key press and call this move function accordingly, depending on which direction was pressed. The next step would be to actually add a way for us to listen for these key presses, and this will be done in game.js. And it turns out that like browsers have this very handy thing called window.add event listener. And what this does is it defines a way for us to listen for certain, as the name suggests, events in a way that's like very similar to sockets. So we'll listen for a particular event. In this case, the event is called key down because anytime a key is pressed on your keyboard, this key down event will be emitted. And we'll want to call a callback function whenever we actually like see that event. In this case, the handle input function we just defined from input.js. So whenever we hear a key press, we're going to call this handle input function, which depending on which key was pressed, call a move function that will emit a socket event to the server. Similarly to sockets, we'll also want to clean up this listener when we leave this page, and we can do that with just this very similar syntax, remove event listener. Cool. So now whenever we like press inputs, we should be like calling this move function at the end, which does a socket emission. And just to kind of like demonstrate that this is actually happening, let's add a console log here. And then if we navigate to our browser, navigate to our game, we should see that when we press the arrow key, as it should in the console. It might be a little small, but you can see in the console that like whenever I press an arrow key, we're logging the direction that I press. Cool. So now, as with all of our socket communications, the next step would be to add a listener for this event that we're emitting. And this time we want to add the listener on the server side. So if we navigate to server.socket and we look at line 61, this is essentially like the function that runs when the server socket manager starts up. And we'll simply want to add a way for the server to respond to these move events that are being emitted by each client. So again, this event was called move, and we'll want to pass in a callback function that will be executed on move. Specifically, what we want to do is we want to get the user that sent this socket emission. And we can do that with this get user from socket ID function. And we'll want to move that user in our game state. So we'll call this move player function that we haven't defined yet, though we'll define that in a second. But essentially what this is saying is every time we get a socket event called move from our clients, we're going to want to move the user that sent that with this move player function in the direction that they pressed. So finally, if we navigate to gamelogic.js, which is where we'll actually define this move player, you'll see kind of there's this to do here, which is to actually move the player in our game state that we're holding. So this is going to be a little bit repetitive, but essentially we're just going to check like whether the direction is any of the ones we're expecting. So if it's up, we're going to want to modify our game state so that the player that's being updated, so players.id, we want their position to increase. Let's just say like in this example of I10, this would probably be some parameter that you experiment to make your game look smooth. Yes. We'll specifically want to move the Y position of the position. Similarly for down, if the player's pressing down, we want to decrease the Y position. If they are pressing right, we'll want to increase the X position. Wait. And then if we're moving left, we want to decrease the X position. So this will modify our game states. And that modified game state will be broadcast to all of the users in which right here in this set interval function. So again, like 60 times a second, we'll be broadcasting this updated game state to all the users. So now hopefully if we navigate to our local host, once again, we should see that. Oh. Mhm. Gotcha. So I forgot to pass in the direction for the socket here. So remember that like when we emit this socket event from our client, we're also passing a direction along with it. And that direction will need to be passed to the game logic function to move. Okay, cool. So now when we press our arrow keys, we should see that we're able to move our user. And remember what's happening is on the client side, we're listening for some inputs. This is in game.js, which will then call this handle input function, which will eventually downstream through a bunch of socket call or function calls, emit this socket event called move. We'll listen for this socket event on the server, and we'll tell the server to update the game state accordingly whenever we hear that socket event here. This will update the game state on the server, and that new updated game state will be broadcast to every single connected client with this function, again, that we've written earlier. And finally, that updated game state will be displayed on our client in the Canvas Manager file with this draw state. So yeah. Yeah. That's a good question. So the question was like, didn't we say that the inverted, like the Canvas coordinate system was inverted in the Y? And that is true. But if you look like in our draw player function, there's this thing called convert coord here that we call. And what this will do is it will convert between those two coordinate systems for us. So that's a good question though. Like it's kind of a design choice, but the way we've chosen to implement this is like to use all real coordinates on the server and game state and to only translate those to canvas coordinates when we're about to draw the player. Okay, cool. So that should be the end of step 2. We're now able to successfully move our character around the screen. Are there any questions high level over here? And again, like we know it's very fast, but feel free to either come to office hours or post on Piazza if you're working through this workshop on your own and you come up with some questions. Okay, cool. So I guess I'll pass it off to Kenneth to walk through adding food and eating other players.
Cool. All right. So if everyone could run git reset hard and git checkout W10 dash step 2, or you could just follow along on the screen, up to you. It is a fast workshop, so don't worry about like live coding with us. Step 3, right? Yeah. Sorry, step 3, not step 2. Oh, these slides are not. All right. Anyway, so this should be step 3, not step 2.
Oh, yes.
Oh wait, the slides went backwards for some reason. All right. Anyway, all right. So git checkout step 3, W10 step 3, and then in this one we're going to be trying to eat food. So before we start, can anyone like tell me something that we might need to implement in order to like have food in our game? It can be anything. Any ideas? Yep. Yeah, exactly. So the answer was like checking to see if a player and a food are on the same like tile or like same area. And we'll define like a helper function later for that to like check if a player can eat a food. Any other ideas? Yep. Yeah, exactly. Spawning food into the game. Another idea? Yeah. Yeah, exactly. So we want to increase the radius of the player if a player is able to eat the food. And just some other general things are like removing the food actually when like a player eats the food. Another thing is like actually rendering the food on the canvas. So we need to do some work on the front end for that. So we're going to do all of that in this step. So we're going to add like spawning food. We're going to add some checks to see if a player can eat food. We're going to increase the radius of the player once the player eats the food. And we're going to remove the player, or we're going to remove the food from the game once the player eats the food. So here's sort of like what it might look like at the end. The food is kind of small, so you might not be able to see it that clearly on the board, but essentially we have like the food, which is like 2 pixels wide. And when the player hovers over the food, it gets absorbed into its mass and the food gets removed from the game. So we're gonna have like 4 substeps to this step. First, we're gonna add food in general, like being able to spawn in food. In the next step, we're going to be able to check if any players are able to eat food. So we're going to have a function that does that. The next step, we want to be able to remove food from the game whenever we want. And then finally, in the last substep, we're going to update the game state to spawn in food periodically. And we're also going to check every tick to see if players can eat food. So there's a lot of text on the slide, but the 4 substeps are essentially what I just said earlier. So let's go through it together. So if everyone's on W10 step 3, we can start coding. All right, so the first step is going to be to add food to the game state. So let's go ahead and go to game logic, which houses our game state. And in this case, it's a design choice, but we're choosing to represent food as just an array in our game state. So in this case, let's just call our food array just food. So now once we've introduced this food array to our game state, we can go ahead and define the spawn food function, which will just spawn food whenever we want. So this is a bit of a mouthful. So recall that we just defined the food array in our game state. And in this case, it's an array, so we can just push something to the array. And can anyone tell me like what we might want to include in our food, just as like some properties of a food? Yeah. Yeah, location. We're just gonna call that position. Yeah, radius, nice. And then just one last thing we want to include is just color, because we want to like spice up our game and include some random colors for each of the foods. So let's go ahead and code up these properties. So position, we have this handy like get random position function that we defined earlier. The radius, we're also going to hard code in as just like a food size. It's just hard coded in as 2 right now. And then finally a color, similar to what we did for the players, we can just get a random color by using the same like weird syntax of getting like a random location in the array. All right, so now what this function will do is it'll add a food item to our food array in our game state with these 3 properties. All right, anyone have any questions on spawning food and our game state? Cool. So the last thing in the substep that we want to do is go ahead to our game file and, oh, sorry, not game file, go to our canvas manager. And we're going to actually want to render the food on the canvas. So let's go ahead and right under where we draw the players, let's draw all the foods. So the syntax is essentially the same. Instead of player, we're just going to take in the food. So object.values. And for each of these foods, we're going to render it on the canvas. All right, so now we've defined like a helpful function to spawn in food. And now we have the ability to draw the food on the canvas once we actually spawn in the food. Awesome. So now let's move on to step 3.2. In this substep, we're going to define a function to check if any players can eat any foods. So can anyone tell me like where that might be? Like, would it be on the client or the server? Or actually, raise your hand if you think it should be on the client. All right, what about the server? Okay, we have a couple of hands there. So yes, you're right. It should be on the server. Recall that all the game logic in our game should be on the server side, or else like it's not going to be like safe. And if clients like get not in sync, we're not going to have like a ground truth. So we want our ground truth to be on the server side. So if we go ahead to our game logic file, this is where we want to define the function to check, if any players can eat foods. So let's scroll up and go to step 3.2. We've defined this handy function called compute players eat foods. And what this will do is for each of the players, we're going to call this helper function we defined here that checks if a given player can eat a given food. And we'll get into that in the next substep. But for now, let's just call this on all the players and the foods. And what we're going to do is we're going to attempt eating pairwise. So for each player and for each food, we're going to attempt like to see if the player can eat that food. And it might seem like a bit like time consuming to do that because like what if we have like a bunch of players and a bunch of foods? You're right about that. Like it's just a design choice in this game because we don't think that a lot of players will be on at the same time. But when you're coding your own game, it might be helpful to think of like more optimizations to check, if things can happen in your game. So let's go ahead and code this up. So essentially what we're doing here is if you see that there's 2 for eaches, it's just a double nested for loop. We're just iterating through the players and the foods. And then we're going to call this helper function where we can check if the player can eat the food. All right, any questions on this function, compute players eat foods? All right, so in the next substep, we're gonna actually define and call a function that will remove food. So let's first call the function. So we've defined like this long function here that we just called and compute players eat foods, which will check to see if the given player can eat the given food. And I'll just walk through this function real quick. We're getting the positions of the food and the player. Those are these 6 lines here. Then we're getting the distance between the player and the food. And then we're having 2 checks to see if the food is within the player's eat range. And then also to see if the player is big enough to eat the food. And then in that case, we absorb the mass into the player. And the last thing we have to do is actually remove the food from the game because we successfully absorb the mass into the player. We don't want like the food to remain there. So let's just call remove function or remove food function. And let's define this remove food function. There's going to be a bit of ugly syntax here, but the ground or basically what we want to do for remove food is just remove the food item from our food array in our game state. So let's go ahead and say, let's code this function. So what this line is doing is it'll get the index of the food item. And since foods are objects, there's only going to be one of that object in our food array. So we can safely just get the index of the food item by just calling this JavaScript function index of. So now that we have the index, we check to see if it's not -1, which means that we just want to make sure that the index is valid. And if the index is valid, we're going to call a JavaScript function called splice. And what this will do is it'll essentially just remove this index from the array. And like this one means that we're just deleting one item from the array. All right. Any questions on remove food? Cool. So now we have the functionality to spawn in food, remove food, and we have this check to see if any players can eat any foods. The last substep we want to do is we want to define a function to check if there are enough foods in the game. And also we want to add all these food functions to the game loop. So we go here to check enough foods. We just want to basically spawn in food whenever there's like not enough food left in the game. So since it's just an array, we can check to see. We're just going to say like if there's less than 10 foods in the game, we want to spawn in more food. So we can just spawn food. And the last thing we want to do is add all these to our update game state function. Like recall that Michael defined earlier this update game state function that will be called like every tick. And we haven't actually put anything in it, but now we finally want to like be able to add some, live updates to our game. So the 2 things that we just defined are like compute players eat foods, which will again attempt all pairwise eating between players and foods. And then we're also going to want to check if there's enough foods in the game. And now if we go to our client, we should see that there are foods here, and we sign in. If we hover over food, supposedly this should work. The food should be absorbed into the player's radius and the food should disappear. Okay, there's a bug. Of course there's a bug. So it looks like the remove player was not, defined properly or something with the removing food. So let's see. Okay, that's it. So in this remove food function, or when we called remove food in our player attempt eat food, we didn't actually like pass in the food. So that's not going to work, obviously. So let's just pass in the food here. And then now, hopefully, when we go to our website, we have a player, and when it eats food, nice. So the food is absorbed into the player's mass, and the food disappears from the game. All right, any questions about this step? Cool. So let's git reset hard and git checkout W10 dash step 4. All right. So Agario obviously isn't complete if we can't eat other players, right? Like we've defined all this socket work for nothing so far because um, who cares if like two players are in the same game if we can't eat each other? So let's define some functions in order to eat other players. This is sort of the demo that you guys should see after we finish this step. We should have a player being able to eat another player and absorbing its mass, and the other player should be removed from the game. So this step sort of mirrors the previous step. So if you remember, in the previous step, we added functionality to check if a player can eat a food. We also added functionality to check all pairwise eating between a player and foods. And then also we added all these functions to our game state. And also we removed the food from the game once it was eaten. Similarly here, what we're gonna want to do is, firstly, we're gonna want to define a helper function that will check if a given player 1 can eat a given player 2. If it can, it will store player 2 in this global array that we'll define called players eaten. In the next substep, we're going to want to attempt all pairwise eating between players. So we're going to define, or we're going to call the function we just defined in 4.1, which is player attempt eat player, in this new function called compute players eat players, which will attempt all pairwise eating between the players. In step 4.3, we're going to actually implement remove player. So we're going to remove a player from the game once it's been eaten. And then finally, in the last step, we're going to update our game loop, similarly what we just did, which will just check if players can eat players every tick. All right, so let's dive in. In 4.1, we're going to first define our function player attempt eat player. So there's a lot of words here, but don't worry about reading it because I'll explain this function. So can anyone actually tell me like what this function should roughly look like? Like what we've seen before in the last step. Yeah. Yeah, exactly. So yeah, we want to get the positions of the players, get the distance between them, and like do some checks to see. And then if the checks are valid, then we want to remove the player from the game. And this is like eerily similar to like player attempt eat food, which we have down here. So we're just going to essentially implement the same thing again. So let's start. It's going to be, I think this is like one of the longest functions in the workshop. So just bear with me while I code. So let's first get the player 1 position. And similarly, let's get the player 2 position. And the annoying thing we have to do is like we actually have to get the X and Y. So let's just extract these fields. And now that we've gotten the positions, we can just get the distance between the two players. I'm just going to copy this in because it's kind of annoying to type. And now let's add in some checks. So the first check that we want to see between two players is whether the player 2 is within player 1's eat range. And this eat range is like something arbitrary we define, which with these constants above, like edible range ratio. So let's go ahead and implement that. So what this will do is it'll check to see if like the distance is less than like player one's radius times like some arbitrary range ratio. This is just for like smoothness in the game. You can like obviously in your game you'll have some heuristics, and you should be able to like define those in any way you want to like make your game smoother or like work better. Okay, so now that we have that check, one additional check we want to do is check if player one is actually big enough to eat player two. So this is just checking, getting player one's radius and like, again, some arbitrary like edible size ratio. And checking to see if that's bigger than player two's radius. Okay, and in that case, what we're gonna do is similarly as when the player ate the food, we're gonna have the player eat the player. So the radius should increase by player two's radius. And then finally, this important step, which I had a bug in last step. One important thing we have to do is actually remove the player. So we won't remove it directly in this function, but we're just going to add it to our players eaten array. So once PID2 or once player two is eaten, we add it to this players eaten array. All right, that was a long function. So any questions on that function? Cool. So let's move on to step 4.2. So what this functional or what this step will do is we'll actually just call the function that we just implemented pairwise on all the players. So we have some infrastructure here. Like first, we're checking to see if there's actually two players in the game, two or more players. And then we're gonna call for eaches on each of the players or on the players array to check to see if like the players can eat each other. So let's just call the function we just implemented on player ID1 and player ID2. All right, so what this function will do is it'll attempt all pairwise eating between the players. All right, now that substep is done, let's move on to step 4.3, where we will call remove player on each eaten player. So recall that in this function, we stored what players should be eaten in our players eaten array. So actually, we want to be able to remove those players in the players eaten array once our attempt eating is done. So in this players eaten, we can call for each, which will just delete each of the player IDs. Yep. Mhm. Yeah, that's a good question. So I think honestly, like safe coding practices is probably just to like make sure, like to add a check to see if like player ID1 is not equal to player ID2. I think it just worked out in this function that it'll never be the case that like a player can eat itself, just because of like the checks we have here.
Specifically like the size will never be like greater than itself, if that makes sense.
Yeah, so in reality, like you probably want to add in that check. That's a good, thanks for pointing that out though. So yeah. So after we've attempted like all pairwise eating between the players, let's actually remove each player from the players eating array. So again, let's call remove player from or for each of the players on the player ID. And then down here, you can see our remove player function is just going to check to see if like the player is actually in the array or in the object, and then delete the player if so. And then finally, in step 4.4, we're going to want to add this function to our game loop. So like our function is like basically useless if we don't add to the game loop because we're not going to be calling it. So in this update game state function, let's just call compute players eat players. And again, this will attempt all pairwise eating between the players. And now if we go back to our game, and we have two players. So the left side is green and the right side is orange or yellow. So if we're big enough, we get big enough. Let's try eating the other player. Okay, so as you can see, the player who was eaten was removed from the game and its mass was absorbed into the other player who ate it. And we can still eat foods. All right, any questions about this step? Okay. All right, so let's run git reset dash dash hard and git checkout w10 dash step 5. Okay, so the basic rundown of this step is we're just gonna add in respawning and winning. And like a game is not really a game if you can't win, right? Like we want to win the game and be able to respawn. So let's make the game replayable. Recall that there's like two ways to communicate with the client and the server. We have sockets and APIs. For the game updates, we needed to make them, or we needed the game updates to be fast and live. So we use sockets. But in this case, we'll use an API for spawning because we don't need like super speed for like spawning in a player in the game. So what we'll do is we'll implement a spawn button on the game page. And when the user clicks that spawn button, it'll send an API request to the server, and that server will communicate with the server socket and game logic to actually spawn a player into the game. I think we are running low on time, so I think I'll just talk about the most important concepts in this workshop, and if anyone wants to like have a recording, actually we'll just like make a recording with like the last step. It's not like super important compared to like the other steps in the workshop, but there are a few important concepts that I want to point out. So I'll just talk through the steps and like sort of point out the important parts of them. So in the first step, we're gonna actually like not make a player spawn in automatically when the socket connects. And we're going to like make some helper functions to help the player like actually spawn into the game. In 5.2, we're gonna like implement API endpoints to allow a post request from the client to spawn in a player into the game. In 5.3, we're gonna actually add in like a spawn button into the game page. And like that will call the post request to spawn a player into the game. In 5.4, which is like a very important step, we're gonna actually want to clean up like after a player disconnects or when the socket disconnects from the game or from the website. And I'll talk a bit more about that just in a few seconds. And then finally in step 5.5, we're gonna add winning to the game. So we're gonna check the win condition on the server side and display the winner on the client. Just like as a quick check of understanding, for the last step, if we add winning, like where do you think we should put the check win function? Like where on the server side? So it should definitely be in game logic because that's where like all the ground truth logic of our game should run. But like under which function should we like check the win? Yeah. That's a good idea. So players eat players. Or do you mean like compute players eat players? Or
Oh, yeah, that one.
yeah, exactly. Yes. So I think with if we put the check win condition in players eat players, it like might check it too frequently, or it might like we might enter a state where we declare a winner even though like there's no winner, just because like we haven't fully finished like checking all the players eating players. So it's generally best to check the win in like the update game state function. And recall that we're like running this function once every server tick. So if we just add like a checked win here, we're gonna check the win at the beginning of every server tick. And that'll allow us to actually like declare a winner when there is a winner, when the condition is met. So that's one important part of this step. All right, and then just one like note about step 5.4, which is like another important part of this step, is like, why do we actually have to like clean up? So like we're gonna want to clean up when a socket disconnects from the website, and also when a player leaves the page. So let's say we have like a client joining the game, and when the client presses the spawn button, it's going to send an API request to the server, and the server is going to say, oh, I want to spawn in a player. Let's say more clients join the game, and the server spawns in more players, and there's a bunch of player objects hanging around in the game state. But when clients leave the game, if we don't clean up the game state, we're just going to have a bunch of players in the game, even though they're like inactive and unable to move. So let's say we have Joe, which is a client, and the server and Joe like just loses internet because he's not connected to MIT Secure or something and sleeps. The server, what we want to happen is we're going to want the server to take Joe's session and just like put it in the trash. And this will clean up the game state and make everything anew again. So the main idea here is we're going to want to remove the player from the game under two conditions: when the socket disconnects from the website, or when the player navigates to a different page. So again, we'll record step 5 separately and post it, but you guys finished Gamebook, this was like by far the toughest workshop in all of Catbook. So congrats on like following through. Thanks for coming. I just want to like point out some key takeaways before we leave. So if you like do get reset hard and check out W10 complete, you should be able to see the final product. We've added some things in like sprites, map bounds, so you don't like go all the way like off the canvas. Server auto reset, so like you actually like can play the game again. And some just like general extra styling. You can also see this at weblab.is/example if you want to check out the game. Okay, so before we leave, I just want to like clarify some takeaways. In case you like didn't understand the workshop, these are like the most important things you should take away. So please make sure you understand this. And if you don't, like come to office hours or post on Piazza. So again, sockets help us enable like fast live communication between the server and the client. And API endpoints are for like a bit slower and like data communication between the server and the client. We introduced HTML Canvas today, and it's a good way to render animations on the front end. Michael coded up event listeners on the client side, which allow the website to take in user input. Also, we noted that game logic should live on the server. We want the ground truth to be on the server and not, bouncing around the clients. Also, we store this game state object on the server side, which stores the ground truth of all the game like components that we want. Additionally, we use a server socket to broadcast live updates to the clients and use like a client socket manager to receive updates from the server. And note that like the socket name should be the same between the server and the client to actually like have the client receive updates and the client sending updates to the server. And finally, we need to clean up. Upon a component unmount or a client socket disconnect, we have to clean up the user from the game, whether that be like despawning or like removing the game or removing the player from the game state entirely. All right, so that was a lot. You can come up to us during lunch if you have any questions. We'll also make the recording. But congrats on finishing all the workshops and congrats on finishing game. And thanks for tuning in. All right, so hi everyone. This is just a continuation of workshop 10. Unfortunately, we didn't get to step 5 during the actual lecture, so I'm just going to be going through the coding part of step 5 right now. So just to recap, previously we literally just added all the game functionality, all the main game functionality that we need for our Agario game. Previously, we added the game page, then we added like being able to move on the canvas, and then we added players being able to eat food, and then finally we added players being able to eat players. So now let's run git reset dash dash hard and git checkout w10 dash step 5. So I'm going to run that right here. All right, so let's get on the same page. The next step, let's say that we want to be able to replay the game. Let's add in some functionality to respawn and win the game. Recall that there's two ways to communicate with the client and the server. The first way is to use sockets, and we use sockets for game updates because we needed them to be fast. The second way is to use an API endpoint. And for things like spawning and like despawning, we're going to use an API endpoint because we don't really need that much speed for them. So just an overview of what we're going to be adding. We're going to be adding a spawn button, and we're going to add the spawn button to our game page. And when we click the spawn button, we're going to send an API request to the backend, which will communicate with the server socket and the game logic to actually spawn in the player into the game state. And then finally, the server is going to communicate that information back to the client, and the client is going to be able to render the player and get information through updates. So let's break this step down. There are 5 substeps in this step, and let's go through the coding portions. So the first substep is right now, like players are being spawned when the socket connects. Let's remove that and actually just make functions to spawn in players instead. In the next substep, we're going to add API endpoints to use those functions that we just defined. In 5.3, we're going to actually add a spawn button on the game page and make it call this API endpoint that we just defined in 5.2. And then 5.4 and 5.5 are sort of the most important steps in this step. In 5.4, we're going to actually clean up after a socket disconnects and after a player leaves the page. And in 5.5, we're going to add a win condition on the server and display the winner on the client. So actually, 5.5 is a bit less important than 5.4. 5.4 is mostly what we want you to take away from this step. The fact that you have to clean up after a user exits the website. Yeah, so actually before we jump into the slide, let's do the live coding session. So the first thing that we want to do is go ahead to server socket. And let's look for 5.1. All right, so it looks like we have 2 utility functions here. One that will add user to the game and one that will remove the user from the game. And these functions are more or less straightforward. Recall that in the game logic file, we had a function that will spawn in a player. So let's just go ahead and add user to game. Let's just call that function. So game logic dot spawn player. And let's say the ID that we give is user dot underscore or dot underscore ID. Recall that the user object that we pass into this function is going to have an underscore ID field. Similarly, for remove user from game, we can just call the game logic function remove player on this user ID. Like so. All right, so the next thing that we want to do in this step is to actually remove the call to spawn player as soon as a player connects via socket. So recall that like when we log into our website, actually a player spawns in even if we don't navigate to the game page. And this is because we just automatically spawn in a player whenever a socket connects to the website. So let's remove this call. And if we remove the call, we won't automatically have a player spawning in when a socket connects. All right, so that's it for 5.1. Let's move on to step 5.2. And in this step, we're going to add API endpoints to actually use the functions that we just defined, which is add user to game and remove user from game. So remember that all of our API endpoints are housed in api.js on the server side. So let's go ahead and code up these to-dos. So the first API endpoint we want is a spawn endpoint. So recall the syntax for an API endpoint. In this case, we want a post endpoint because the client is going to be sending information to the server. Namely, like the client will say, oh, I want to spawn in a player now that I've connected to the website or connected to the game page. So let's define an endpoint called spawn. And then recall that there's a rec and a res field. And let's check to see if the user is actually, a user on the website. It's not undefined. If so, we can call the add user to game function from our socket manager on the user. And functionally, like this does nothing, but we can just send an empty object as a result. And then our other endpoint should basically be the same thing, except we're going to call this the despawn endpoint. And instead of calling add user to game, we're just going to remove the user from the game. Okay, so now we have those two API endpoints that we can call from the client. The next step we want to do is actually add a spawn button on the game page that calls the API endpoints that we just defined. So let's go ahead to the client side and go to game.js. Here in 5.3, we already have handily a button here that has an on-click callback function. And in this function, let's say we're just going to call this post endpoint. So /API/spawn. And inside, we're going to create a user object. And this user object is going to have a field called user ID. And we can just use the user ID that was passed in to the prop or via the props. And then finally, in step 5.4, we're going to clean up. So what exactly does this mean again? Well, basically when the user exits the page or when the user disconnects from the website, we want to actually despawn the user from the game. So this is what we mean by cleaning up. So if we go ahead and actually go to server socket and go to step 5.4, this is the same place that we're actually deleting the socket from the entire user to socket map. So this means that the user will disconnect or the user has disconnected from the website. So in this same place, let's just remove the user from the game in case the user is connected to the game. And in addition, we also want the user to be removed from the game if the user navigates away from the game page, even if the user is still connected to the website. In this case, the socket won't actually disconnect, but we still want the user to end the game or exit the game. So in here, in the same place that we remove the event listener, we can send a post request that will be sent to the despawn endpoint and similarly just pass in the user ID. All right, so now we're done with cleaning up all the game state once the user leaves the website or the game page. All right, and then finally, what we want to do is add winning. So there are two parts of this. The first part is in the server in game logic, and the second part is in the client in game.js. First part, we're just going to check the win on the server side. And then the second part, we're going to actually display that winner once the information about the winner is conveyed to the client. So let's go ahead to gamelogic.js and go to step 5.5. Here, we can just add the check win function to our update game state function. Essentially, what this will do is it'll check the win condition at every tick. And it'll check it at the beginning. So, if a winner is declared during that tick, we can automatically just declare the winner and send that information to the client. And just to give a quick recap of this check win function, we defined it for you. It will basically just check to see if a player is sufficiently large to win. If so, then it'll just declare that player as a winner. And this is not exactly the safest code. There's actually a race condition in here, but when you're coding your own websites, it's probably best to deal with all these by thoroughly playing through your website and making sure it works for multiple users. Okay, so now that we've added that to our game state or update game function, let's go ahead to the client side and actually deal with the case where there is a winner. So the first thing we're going to do is declare a React state called winner modal. And what winner modal is going to be is basically a pop-up. It's going to be an HTML element that will just pop up on the screen whenever a winner wins or whenever a player wins. And in React, usually when we have a state for an HTML element, we initialize it to null, so it won't render until we set the state to something. All right, so we've declared this state, winner modal. And now that we have this state in the process update function, let's just declare this if else statement that will set the user modal to something if there is actually a winner. If not, it'll just set it to null. And recall that this process update function happens whenever we receive an update from the server. So if there's a winner in this update, then we actually have a winner and we can just display that on our front end. And the final thing we want to do is actually render the user or render the winner on page whenever there is a winner. So we can just go ahead and display the winner modal right here. All right, so if I go ahead and run this, theoretically, if there's a winner, the winner should be declared and it should be displayed correctly on the front end. So let's go ahead and run that. And bear with me while I pause my screen share real quick to pull up the website. So usually when you're testing, you want to have an incognito tab and a regular tab. I forgot to pull up the incognito tab, which is why I am pausing real quick because I need to actually sign into my Google account. All right, so okay, if I go ahead and oh, actually, it looks like something is wrong. Um, I actually did want to share this bug if anyone is facing it. So yeah, notice how I have a tab for like my incognito and a tab for my regular Chrome. Actually, in incognito, if you log in, sometimes it just won't work. Like, let's say I try to log in, it won't work. And actually, you have to enable something in incognito. Um, yeah, I think you have to enable third-party cookies. And what that'll do is it'll actually allow you to log in. Yeah, so now I'm able to log in and I can also log in regularly here. So if I go to the game page here, notice how I don't automatically spawn, which is great. I can also get to the game page here. Let's spawn in here. Let's get some food. Getting bigger. Let's also spawn in here. Oh, same color. That's kind of unlucky. Let's respawn. Okay. Um, so left side is yellow and it's getting bigger and bigger. Let's say we want to eat. Oh, we ate the other player. And theoretically, we've coded the win condition to be like the player getting big enough. So player gets big enough, it should win. All right, yeah. So the player won. Actually, you can see right now, like we have the socket number as the actual like winner ID. You should probably change that on your website if you have like a win condition. Um, but yeah, for now we just hard coded this in essentially, or we just coded in it to be the socket number. All right, so let's go back. So you guys have finished Gamebook, and you can check out the complete step to see the full product. But one thing before we sum up the lecture, I just wanted to share like what is a motivation behind like cleaning up. Remember that this is like one of the most important takeaways for this lecture. Um, so like why do we have to clean up the game state after we leave? Okay, so let's say we have a client that joins the game. And the client communicates this by sending an API request to the backend, and the server responds by spawning in a player and sending the update back to the client. Let's say more clients join the game. So the server spawns in more and more players on the backend into the game state. What happens when clients leave the game? Well, if clients leave the game and there's no cleanup, then there's just going to be a bunch of like players in the game state who aren't doing anything and like they're permanently disconnected. But if they can't do anything, then the game's just going to be cluttered with like NPCs. So why do we clean up? So let's say like Joe, we have a client here. When Joe disconnects from the Wi-Fi, or when they lose Wi-Fi or something like that, we want the server to pick up the session and put it in the trash. And everything will be clean again, and we can proceed with the game normally. So the message is to remove player when the socket disconnects or when the player navigates to a different page on the game. And just to recap, socket disconnection will happen when the player leaves the entire website. And player navigating to a different page will just happen when the player clicks a different tab on the website or navigates to a different page on the nav bar, etc. All right, so congrats on completing Gamebook. It was by far the toughest workshop in Web Lab so far, and yeah, you definitely deserve a pat on the back for completing Gamebook. So if you want to see the final product, we've added a couple things. So you can do git reset dash dash hard, git checkout w10 dash complete, and we've added some extra features here. So Namely, we've added some sprites, map bounds, server auto reset, and some extra styling. And you can also go to weblab.is/example to see the full gamebook. And we've added like an LLM thing. With Tony and Andrew added that. So be sure to check out the example website. And again, we've recapped a lot towards the end of this lecture, but I just wanted to solidify some takeaways. So sockets are there to enable fast live communication between the server and the client, while API endpoints are for like slow and data connections. Michael introduced HTML Canvas, and HTML Canvas is a great way to render animations on the front end. Event listeners on the client will allow the website to take in any user input. And in this case, we use like the event listeners for key bindings. All game logic should be done on the server. Remember that we want the ground truth game logic to be on the server so that, we don't have, game state bouncing around the clients and, losing the ground truth of the game. And on the same note, the game state stored on the server is where the ground truth of the game should be stored. And there should only be one ground truth. Additionally, we use the server socket to broadcast live updates to the clients and use a client socket manager to receive updates from the server. And finally, upon a component unmount or a client socket disconnect, we have to clean up the user from the game, or else the game state will be cluttered with unusable users, and that's not what we want for our game. All right, so congrats again on making Gamebook, and thanks for tuning in.